Hello viewers, welcome to my YouTube channel. In this video, I will be showing you the correct answers to the just concluded Wassce chemistry practicals on volumetric analysis. So don't forget that your endpoint, the endpoint that you may have gotten may not be the same with the ones that were gotten in other places, but it is expected to fall within certain range. Okay, so the average volume of the acid will be the sum of, let me say, the 2 to 3 titers that you got divided by the number of titers. So in my own center, we got an average titer of 29.10. So the 29.10 represents the average volume of acid used, which is your VA. Now the VB is simply the volume of the pipette you used in the titration. So one of the solutions had its concentration given, and that is the standard solution. So concentration B was given as 0.12 mole per dm cube in the question, but that of A was given as 2.3 grams in 500 cm cube of the solution. So these parameters were given. So we're going to be using the parameters given in the question to solve the questions on the board. All right, now let's see the questions that were asked. We're asked to calculate the concentration of A in mole per dm cube. In mole per dm cube. So we need to use the information provided. We were told that 2.30 grams of solution A was contained in 500 cm cube of the solution. Now, to find the mass concentration of this solution, we simply need to find the mass of the solution in 1000 cm cube or 1 dm cube of the solution. So, if 2.3 grams of solution A was contained in 500, that means that x grams of solution A will be contained in 1000 cm cube. So when we cross multiply to find the value of x, then we'll now have 2.30 grams is in 500, x grams is in 1000. So what it means is that 500x will be equal to 2.3 times 1000. So x will be equal to 2.3 times 1000 divided by 500. So by the time you divide 500 with 1000, it will give you 2. So 2 times 2.3 will give us 4.6 grams. So this is the mass concentration of A. Now to convert the mass concentration to molar concentration, we simply need to employ the formula M is equal to small m over capital M. So which is 4.6, and the molar mass of HCl is 36.5. So you divide 4.6 by 36.5 to get the mass concentration in the molar concentration of A, which is about 0.111, 23 something mole per dm cube. So this is the correct answer to question number 1. Okay, let's go to question number 2. Question number 2. Alright, question number 2, which is 1BII, says find the number of moles of acid in the average titer. Now remember, the average acid used, average volume of acid used that we got in my center, we got 29.10 cm cube. So if I am asked to find the number of moles of acid in this average volume, I will simply need to employ the formula N is equal to CV over what? 1000. N is equal to CV over 1000. And the volume in this equation represents the average volume that we have here. So remember that the concentration of the acid that we got, which is our CV, we got 0.11123 mole per dm cube. So when you substitute, you have 0.112 times 1112 times the volume, which is 29.10 divided by 1000 divided by 1000. So at this point I would like to employ my calculator. So 0.1112 times 29.10, 0.1112 times 29 times 29.1 divided by 1000. That is a 1 dm cube approximation. Then we have 0.003, 0.003, approximately 0.003 mole. So the number of moles of A present in the average volume of the titration or the title values is 0.0013. 0.003, I mean. Alright, so let's go to the next question. The next question says we should find the number of moles of B in the pipette. Find the number of moles of B in the pipette. Alright, now the volume of the pipette used in my center is exactly 25 cm cube, and that's the volume we're going to still use in the same expression. N is equal to CV over 1000. So the V here will be the volume of the pipette used in your scope, so which is 25 cm cube. So remember the concentration of B is 0.12 mole per dm cube as given in the question. So we're going to substitute to find the number of moles of base in 25 cm cube of the pipette. So which is 0.12 times 25 divided by what? 1000. So what it means, I'm simply dividing 0.12 by 4, because 25 divided by 1000 by 40, sorry. 25 divided by 1000 is 40. So 0.12 divided by 40 will give us the equivalent answer. Will give us the equivalent answer. So we have 0.12 divided by 40. So that will give us 0.03, almost the same thing as the first answer, 0.03. Okay, so if we have, let me go straight to the next question, which says we should find the number of moles, the mole ratio of acid to base. So to find the mole ratio of acid to base, don't forget the first answer we got, that's where we calculated the number of moles of acid used, we got 0.03, and now the number of moles of base we are getting now is 0.03. So the mole ratio is simply, gotten by dividing these values, by themselves, because they're almost equal. So by the time I say 0.03 divided by another 0.03, it will give me 1. So what it means is that the number of moles of acid to the number of moles of base is 1 over 1, which is 1:1. Okay, so that is the answer to the last question. Alright, so I believe you've seen all the answers. So these are short answers to the just concluded Wassce chemistry practical questions on volumetric analysis. In the next video, I will be discussing I will be telling you the correct answers to the salt analysis, and then possibly question number 3. Alright, thank you and God bless you.